Good day, class. Today we are going to be looking at parameter passing techniques in C++ functions. In the last two videos, we have treated library functions and user-defined functions. So today we want to dive deeper into functions by looking at parameter passing techniques in functions. What are parameters? Parameters are values passed to functions. The data that your function receives that it uses to perform its task are called parameters. Then take note of this jargon. When you hear argument, argument is the data that the calling code passes to the function. So the caller sends argument, while the function provides space for the argument to come in. As I said, the data that the caller sends, the space that the function reserves for it is called parameter. So when you send argument, it must match the parameter in terms of data type and in terms of order or arrangement. Okay, so parameters are values passed to functions. They are used to provide input data for our functions. Okay, we have basically two main, but three or more. But let's call it two main basically. We have call by value, we have call by value, we have call by reference, and then an extension of reference we call what we call by constant reference. So constant reference is still called by reference. It is a modification to it. So we have basically call by value and call by reference. When you are calling by value, what are you doing? When you call a function and pass parameter by value, you are only passing a copy of the argument to the parameters, meaning that you are not sending the original, you are sending a photocopy. An image of the data is what you are sending, so that it now leads to duplication of value. Now the value is in main, as we are calling from main. The data is in main. Another copy of it is also in the function that is going to work with it. So a copy of argument is passed. As a result, when you make changes in the function on the value, it does not affect the original value since it's a copy. So when the function makes any change to the copy, it will not affect the original value. That's one of the key things about call by value. Here's an example. Let's just look at this function. Forget about the name that we call this function. What we want this function to do is to change the value of x. So I want to change the value to 10, or maybe to a multiplication of the value. I say change it to 10, for instance. So what should happen is that after this function has been called, then the function that called it, the original value should change if it's actually a change. But with what we have, this change is not going to occur. Even though s value will be changed, in the original value it will not be changed because it is called by value. So one of the disadvantages of call by value is that it uses more memory because there is always a duplicate of values. So the features, it is safe. Safe in the sense that when you make changes to the original value, to the function, to the parameters, it does not affect the original values. So the original value remains unchanged. That is in call by value. What about call by reference? What happens? In this case now, the function receives the actual variable. That is to say, both the function and the main or any other function that calls it are holding the same value, the same data. It's not a copy now. You are passing the original value, or rather you are passing the address of the original value. It's like giving somebody the key to your house. You have key, you also give the person a spare key. So two of you can enter the house and do the same thing. because you have actual access to the how. In the same way, when you pass parameter by reference, it's as if you are giving the function a spare key to the data, so that changes that you make in the function will affect the original value, because two of you are accessing the same memory. To do that, you have to use a symbol called the reference symbol, which is the ampersand symbol. That's what you use to know if a function is receiving parameter by reference or by value. So let's look at the change program we looked at before. We say change int x. So now in this case, now not just x, we added ampersand to x. So in this case now, any change you make to x will affect the original value. So this ampersand means the key to the variable. I'm giving you the key, a spare key to the memory. So anything you do to that memory will affect the one I have, the original value. So what I've called by const reference. In this case now, the function receives the actual variable, of course, like we have, because they are giving it a spare. But changes does not affect the original value. So you see that this guy is behaving like call by value and call by reference. Meaning that, yes, I'll give you the original key, the key to the original value, or the key to the address. But the only thing you can do is to see what is inside, but you cannot change what is inside. You can open the door and look at things, but you cannot change anything in the room in that case. So when you pass by constant reference, what you're actually doing is that you give the person key access to the memory, but with a restriction that you cannot make changes to it. It also uses the ampersand symbol along with the const keyword. So our change again, say that here now we have const, the variable type, the type, ampersand, then the variable. So in this case now, you have access to the memory, but you cannot change the content. So this constant reference takes advantage of both call by value and call by reference. It does what the two were supposed to do. The data is protected, memory is not duplicated. So we are going to be looking at our codes to see what and how this works. So here is our code in code blocks. So as you can see, we have a function declaration called change. Remember what we intended to do, we want it to change the value. So in this case, this is the function declaration and this is the function definition. So what we want the code to do, the change we want the code to do is to multiply the value given to it by 2. If you give it a number, you should multiply it by 2 and then make that change. So that's what we want. So in the main, we have int, we declare a variable called val, the value is 10. We want to change this value, we want it to be times 2 of the value. That's why we needed this function called change, which multiplies the value by 2. Okay, so we call this function after we now display to know what they return. After the change has taken place, let's see whether change already happened. So we have two outputs. One, inside the main function, we'll see the value of val after the change function has been called. They're also going to see the value of val inside the change function to see whether what happens inside the change function, if it's also repeated or affected in what happens in the main. So we'll run this program. Wow, we can see that inside the change function, the value of val is 20, while inside the main function, the value never changed, it still remains 10. So this is possible because we passed the parameter by value. And when we pass parameter by value, we said that is a copy that the function will receive. So this change function only received a copy of this val here. It received a copy, which is 10. And then whatever changes that happen to it only happened inside the change function. It didn't happen outside the change function. That is why when we printed val inside the main function, the value remains 10 because we passed it by value. So we're going to look at passing it by reference. What happens? Just put ampersand here in the var. When we put ampersand here, it now means this change function is not going to be receiving. So remember to do it also in the declaration too. It means that this change function is not going to be receiving a copy of value, that is going to be receiving access to the same variable. So whatever changes we make here should reflect here. So let's run the program again. Good. As you can see now, inside change function, the value is 20. Inside the main function, the value is also 20. So if you are going to be writing a program that requires that changes made in the program does not, and the function does not, reflects in the original point of call, you use call by reference. So we are going to now try also call by constant reference. Call by constant reference. So to make it a call by constant reference, we have to include const here, and we also include const. Let's run the program now. Remember, we want to change value. An error occurs. In this case now, we want to make change, or we are making change. This change we are making is unintentionally. That's actually the idea. You don't want the person to make change. So let's see what this error message is telling us. This error message, it says error, assignment of read-only reference. Assignment of read-only reference. So because we said when you pass by constant value, you can only view, you cannot change. So this protects your code. So if you write a program that you don't want, you want to maintain the idea of the idea of memory efficiency by passing address instead of passing which values. You are using reference, but you now want to also ensure that values are not changed. That's why we're using constant reference. But remember, in constant reference, any attempt to change the value, the compiler will not even compile it, because it sees this as error. Not what it says as not what you intended to do. So if you want to use reference and you want to change value, good. That means you have to just use only pass by reference and not pass by constant reference. So we have removed the constant reference by saying that the values have now changed in both. So we have seen passing by value. We said in passing by value that changes made to in the function does not affect the original argument. When we pass by reference, you are passing the address of the variable or of the data. So changes made in the function will reflect at the point the argument was called. Then we'll say if you want to prevent that, you use a constant reference, which allows you to pass address in read-only format. You cannot make changes to it. So the next thing I want us to look at, okay, let's check, compare these different parameter passing techniques and when to use them. So comparing the parameter passing techniques, call by value and call by reference. When we talk about memory, for call by value, it uses a copy of the data, while call by reference uses the original memory, original value. While for safety, call by value is safe because changes made to the original in the function does not affect the original value. While for call by reference, the safety is low because if you unintentionally make changes in the function, it will affect that in the original value. That is why we'll have the constant reference to prevent that. Then for efficiency, call by value is less efficient because it duplicates data therefore taking you more memory. Why this one is more efficient, because both the function and the caller have access to the same memory. Then for call by value, original value is not changed, while in this case original value is changed. When do we use them? When do we use call by value? We use call by value when the original data must be protected, while we use call by reference when the modification or when modification is required. For instance, when you want to write a program to swap numbers, of course you have to modify. So when modification is required, call by reference is the key. Then when passing large data for efficiency, you want to pass a very large data for efficiency, instead of passing the whole value, you just pass the address of the value. That maintains low memory, that is efficiency. Then call by constant reference when modification is not required, and when passing large data for efficiency. Modification is not required, but yet you want to maintain efficiency of not passing copies of the data. So let's look at this final one, passing array. Passing array. So array in programs is not just one value, it's a collection of value. The collection of value. So when you are passing array to a function, what you are passing is actually a pointer to the first element in the array. If there are 10 elements, when you pass an array as a parameter to a function, it is the address of the first element, that is the index 0, that you are passing. So when you are passing an array, it's as though you are just passing a pointer to the first address of the array. So there is need to also pass the size of the array, since it is just the address of the first element that was passed. So when you are passing an array, there is need for you to pass the size also, because when you just pass the address of the first array, the function does not know the number of elements. So when passing an array, you have to pass the first address and the size of the array. So we have an example here. Example, a function called sum array, that is to say receives set of array values and provide their sum. So you see that the parameters are an array. You can see there is no size specified. We don't specify the size of the array. Just mentioning in scores like this will give you the address of the first element. Then we also need to provide the size of the array. So in this case, as we want to find it, I have to declare a variable called total. So we'll now see for in I equals to 0, I is less than the size, I plus plus, then total is equals to total plus each of the score. I think you have done array. This particular code should not confuse you if you have idea of array. So I'm going to take us to code blocks where we're going to look at this passing of array and how it works. So here is a program. We have a function called sum array. Okay, sum array. Let me make it a declaration, which we said is the ideal thing to do. Definition, then declaration. So the is a function that returns integer. The name is sum array. It has two parameters, and it's actually an array, and an integer size. Okay, call it size, integer size s. So okay, I have a declaration at this point. Is the declaration an array that receives a function that receives an array and the size of the array. So now here we just defined a simple array of 4 elements, 2, 3, 4, 5. We now called the sum array by passing scores. Remember how we passed it now. You see the name we passed. We did not add anything. we did not even say score 0. Just mentioning the name of the array is like mentioning the address of the first element. So this scores that we have here now is actually the first element, the address of this first element. So I've provided the address of the first element, which is what this guy will receive, or what this guy will receive now. Then take note that the variable name did not match. The variable name did not match. Remember I told you that in this thing, in what do you call it, in declaration, and it is basically the data type that matters and not this thing that matters. So we are going to, I just want to do some of this so you can see things the way they are, so you know that they happen these ways. Okay, so now we'll now have the function that will get the size and loop through it and give us some. So when we have 2 plus 3 is 5, 5 plus 4 is 9, 9 plus 5 is 14. So let's run and see the total we'll get. Error somewhere. Okay, instead of comma, I use the semicolon. Use the semicolon instead of a semicolon instead of a comma in the declaration. So we're saying the output is 14. The output is 14. So an array is passed, just only the first element. So what if I remove the names completely? You see, the name is not compulsory in a declaration. What matters is what kind of data are you passing. So in this case now, because it's an array, that is why we have this open bracket and block bracket coming after int. Then this is the size. Okay? Then, assuming like we always do, we want to now get the size by calculation int, so that we don't fix it. Int array size. You remembered we said this size of the array divided by the size of the first element in the array. I think that's what gives us size of scores 0. Remember, this is how to compute the size of array. Array size is the size of all the elements of the array divided by the size of the first element in the array. So here now I'll just use, instead of passing a fixed number, I'll pass a variable in case my array size changes. So of course, what happens? Each of the elements in this array is an integer data type, and each integer data type is 4 bytes. So that means this one is taking 4 bytes, 4 bytes, 4 bytes, 4 bytes. So the 4 of them are taking 16 bytes in total. That is what size of will give you. But if we say size of scores, it will give us 16, but the number of elements is not 16. So we'll now need to divide by size of one of the elements. Since all the elements have equal size, that's why we're now dividing it by the size of the first element, so which is 4. So 16 over 4 will give us 4. So let's run this program again. It is safer now. Then even if we increase the number of our elements, maybe 34, sorry, I'm using so comma. We don't need to change the size again, because the size of this particular line 8 will by itself compute the size by itself. So the new sum is now 192. So this is passing array as a parameter. If you are passing array as a parameter, all you need to put is the name of the array, followed by this block bracket, then the size of the array, so that you can use it to manipulate the elements of the array in case you want to look through. Okay? This is very, very clear. You can go back and check it out on your own and see how it goes. So in conclusion, what have we done? We have looked at functions that they make programs modular, reusable, and easier to maintain. In all the three series we have just done, this is basically what we have been trying to talk about. Functions. Functions make your program modular, reusable, and easy to maintain. We also told you that C++ make provisions for you to use some powerful library functions, and for you to also use flexible user-defined functions that meet your specific task. Then understanding parameter passing is crucial in programming. Thank you so much. God bless you. My WhatsApp number, in case you want to contact me, is on the screen. Please do well to subscribe to this channel. Ask me any question. You can ask me via YouTube. You can also chat me up on WhatsApp. In case you want a private tutorial on C++ or any other programming language, you can also contact me via WhatsApp. You can make arrangement for virtual tutorial. Thank you so much, and God bless you.